Hello, everyone. Today we will discuss the optimization of compressed air system when we want to replace open tubes by blowing guns, for example. Every time we want to make our operation more efficient and buying the best components available on the market that are promising the reduction in energy consumption and improvement of the functionality and the quality, we always need to take the holistic picture and take a holistic approach to see the impact of those efficient components that we are integrating. So let's see. Here we have a quite simple system that consists of two machines on that side, four machines on that side, and as well as each of the line connected to the air reservoirs that leads to one of the compressors. This is quite a simplified model. We don't have here filters, regulators, or things like this, but let's just see in each machine, as it usual, we have some cleaning process. So the operator has to clean after this. Of course, it's always better to replace any open tubes that we use for the cleaning by the efficient guns. Let's check it out. So each tube works under the pressure of 6 bar, and as well as we have the machine as the general consumer of 6 and 3,000 liter per minute. So we calculate, and what we see here, we see here the cost of our compressed air system. So it's about 500,000. We see the required cubic meter per hour, required consumption for the compressor, as well as pressure. We need 8 bar at the beginning of our system to supply those machines with 6 bar. Okay, so let's keep it in mind. It's 569,000 euros operational cost or energy cost for this compressed air system. Let's see where we have the problems here. So we have pressure drop here. So it's about 1.2 bar, and as well as pressure drop here, as well as pressure drop here. As optimization criteria, we put here that we don't want to have any pressure drop that are higher than 0.2 bars. So I think it's quite nice. Let's see what the program proposes. How we usually replace open tubes. Of course, we can find in the catalog some information about the analog of the diameter of the replacement under certain pressure. And this is how the blowing force is calculated there, as well as the consumption. And relying on this data, we look for the analogs in our system. So here we can filter it by various criteria as a range connection. Let's say we have a certain connection here, and the program now proposes few options, and here you can see the sounds level, the pressure, the what type of pipe it's going to replace, and very important to see the pressure level. So for example, I want to replace it by this one. So it looks quite efficient. It's 2.6 Newton. It's a bit bigger the blowing force. However, the consumption is lower. So I want to replace by this. By this. Okay, perfect. So I'm starting to replace each single gun by the one that I find in the catalog that has promised me the most efficient operation. And as well as this one. For example, there is not enough maybe on the market, so I want to get this. Perfect. So now I just simply can copy this system of those blowing guns, and I want to use it here the same because I have same machines. So sorry, that's not correct. Okay, so I just want to replace. So we simply put all, choose together all the components here, delete it, and let's copy. So theoretically, we will have a perfect system, right? Because the components are efficient that we saw in the catalog, and we need to have an automatic optimization. So let me just remove this. And we need to have an immediate savings. So probably we'll adjust a little bit the compressor, but in general, we will have immediate savings here. Let's calculate and see. So the costs are actually higher, as well as for 200,000 euros. But the pressure that we require, it's also 8.5 bar instead of 8 bar. What is happening here? The pressure drop here is a bit lower. That is good. However, the blowing guns here are operating on a different pressure. We can see it in the connector that it says us that there is a big pressure difference. So it meaning that the machine, while the machine requires the 6 bar, blowing gun require only 4 bar. And what does it mean? It means that we always need to pay attention on what the component we choose, not just by the force, but as well as the open, as well as the required pressure level. Because very often the system can be just different. It cannot be just that there are no pressure regulators, for example, and blowing gun will not provide the same force as required. So this is always important to consider while integrating your efficient component, that we also consider correct operation system here. What we can do? There are two options. Either we look for blowing guns with the pressure, the same blowing guns with the pressure level of 6 bar that operate at the same pressure, or we install another compressor that operates on the 4 bar. So let's take a look on this. So what we could do, so we just remove these connections here, and we create a new separate system that connects only blowing guns. So this will be the first option. So we create the multi-pressure level system. And in this case, we will probably get some savings. So let's take a look how it will work. So I just connect here, here also, as well as next one. And we'll see what impact it will have. So I just leave it here, and we copy compressor. This is basically the simple model of the source or simple model of the compressor that shows us. So this will be the first option. Delete this part. delete this and this, and let's see how we can optimize. Okay, so I'll copy this again and I bring it here. And I guess I just need to connect it directly to the air reservoir. Okay, we calculate now, and we see that operation of 4 blown guns is going to be only 23,000 euros. Another 23,000 euros here, and the system is about 458. So from 500,070 we went down for 458, and we just add here additional 46,000. So 46,000 will cost the operation of the blowing guns. This is the most efficient solution here. What also is important to remember, let's reduce our pressure drops here. Pressure drops depend on in the pipe depend on the diameter and as well as the length. So we'll just replace and see how we can optimize it. We calculate again, and here we still have 23,000, and here will be already 417 plus 46, so we have less than 460. So basically we just saved 100,000 by optimizing it in a smart way. So we in the following steps. First of all, we replaced open pipes with blowing guns. However, it showed us that the cost would increase simply because we chose the gun that is was good for according to our other criteria. So we chose it, but we forgot to check in the catalog that it's this required pressure was lower. So in this case, if the pressure is lower for a certain amount of applications, it's always more efficient to have a decentralized compressor system. So we get one compressor for the main pressure level and another compressor that we get for the other pipes, for the other applications. Always very important to remember, once we decide to change to a more efficient component, we always need to check also other components along our system. Thank you for watching this tutorial, and hope to see you soon in the next videos powered by Directing, where we check the tips on the design and optimization of compressed air and pneumatic systems.